Hello everyone, this is Karthika from the Department of Biomedical Engineering. Today we are going to discuss about elements of visual perception and biomedical image processing. First of all, what do you mean by digital image? See this picture. This picture, it shows how an input image represented in digital form. For example, the digital image, it contains array of numbers for intensity images. Or else, if in case of vectors, the representation form is a vector, the image is a colored image. And also here, see this grid, here each component in the image called pixel, it associates with the pixel value as single number in case of an intensity image or vector in case of a colored image. We know that. And here, this diagram, it shows the visual perception of a human eye. We know that here the elements of visual perception, it includes, it starts from pupil, lens, cornea, suspensory ligament, choroid, retina, sclera, fovea, optic nerve, blood vessels, blind spot, vitreous humor, highlight membrane, muscle, ciliary body, iris and aqueous humor. And this shows the cross section of a human eye. Here, the lens, which is the main part of a human eye, it contains 60 to 70% of water and 6% of fat. And see this cornea, this shows the clear front section of our human eye. And follow that, we have iris, it controls the amount of light entered into our human eye. And also we have a blind spot and retina. Retina, which normally contains cones and rods, which is called as photoreceptors. In blind spot, there is no photoreceptors. And we have sclera and choroid. Choroid, which is responsible for the blood vessels and oxygen flow in a human eye. And also, we have nerves and sheath and fovea for better elements of visual perception of a human eye in image processing. And also, this shows distribution of rods and cones in the retina. We know that this rods and cones, photoreceptors of retina, is equally distributed in the human eye. First of all, cones, it contains 6 to 7 million elements in human eye, and which is responsible for bright light vision, that is photopic vision. And also rods, which are represented in dotted lines here, and these rods are responsible for scotopic vision, that is dim light vision. And here this diagram, this graph, it shows the degrees from visual axis, center of fovea to number of rods or cones per millimeter square in human eye. Okay, next it shows the range of relative brightness sensation of a human eye. Here the graph, it shows the log of intensity versus subjective brightness. Here the simultaneous range is smaller than total adaptation range because we have two brightness levels. One is brightness A and one is brightness B. Here the difference is shown between scotopic and photopic range. Here also we have scotopic threshold for dim light vision and photopic threshold for bright light vision. And the next one is how an image formed in human eye. Here this shows a normal focus and near side focus and far focus. And this distance from the object to our human eye, the lens, is 100 meter. And once the image is formed in our eye by using photoreceptors of retina, we our human body, it shows the vision in our eye. Here both lens, cornea and retina plays an important role here. The distance focal length is normally 14 mm to 17 mm in general. And next one is in elements of visual perception, the main important one is Mark-Band effect. Here, see this image. In this image, the edges between the bars appear brighter on the right side and lighter on the other side of the left side. That is, it represents and it appears brighter on the right side and darker on the left side. And also this shows the actual illumination. There is no fluctuation here, and in perceived brightness we have fluctuations because of the Mark-Band effect. This Markband effect is due to the high blue strength filters of the human eye. But the image is actual, the perceived brightness getting fluctuated because of the high boosting filters of the human eye. And the next one is same example for Markband effect. Here in area A, the brightness is perceived as darker, while in area B it is brighter. This phenomenon is called Markband effect. And next one is the main element, brightness adaptation of a human eye. It is a simultaneous contrast. And here in simultaneous contrast, all the small squares have exactly the same intensity, but they appear progressively darker as the background becomes lighter here. And one more example for this. Examples of a simultaneous contrast, all the inner squares have the same intensity, but they appear progressively darker as the background becomes lighter. And the last one is optical illusion. Here there is no circle and there is no square and there is no variation in length of the lines, but due to optical illusion, the formation of image in our human eye due to elements of visual perception, it looks like there is a square inside and there is a circle inside and there is a change in length of the lines. That's it. Thank you.